right, thank you all so much for coming to this talk. It has been rescheduled several times, and I am just so grateful that it's actually happening. But yeah, today we're going to talk a little bit about WebRTC. If you have been spending your life online on screens over the last 2 years, then probably you have said you're on mute to someone or someone has said it to you. So today we're going to talk about how WebRTC can solve this problem and many more that you might have. My name is Liz Moy, and I'm a developer evangelist for Twilio. I use she and her pronouns, and if you are building something with WebRTC or really any type of communications, I would love to hear about it. You can find me on Twitter at ecmoy or drop me a line at my Twilio email address. But when I was kind of like looking up stuff for this talk, I was thinking a lot about how we've spent our time these last 2 years. And when I think about something like WebRTC, it is a way that you can have real-time connected experiences with audio, video, and then actually like arbitrary data that you can decide what you want to do with. So there's a lot of really good cases for when we would want to use WebRTC and when we might want to use something else, right? Because I'm sure you all probably recognize the other applications on this screen. You have a lot of options now with how you want to connect with people when you're trying to have a video call, an audio call. So if we think about those situations where we might want to use like a Zoom or a Teams or that kind of thing, if we are talking in a work meeting, you likely have an app that's provisioned by work and that's what you use. You may have had like Zoom birthday parties. I know I went to a lot of those over the last 2 years. Or maybe you have Skype calls with family members. And that's great because you can agree that you both want to have this application that you will connect through. However, there are some cases where it actually might make more sense to have a browser-based experience. And that's really the powerful thing about WebRTC is that it's entirely browser-based. So no matter what type of device you're using to call through, you can use WebRTC to do that if you have a connection to a browser, with the exception of maybe like 3 browsers, which we'll talk about a little bit. But there are a couple of sort of like business cases that I've seen quite a bit over the last 2 years. And I would say the primary one that I've seen as a really great use case for WebRTC is actually telehealth. So if you think about the experience that you might have with a health provider, with getting an appointment, if you can just send someone a link, maybe by WhatsApp message or email, they click on that link and then they join the appointment, that is a much better user experience than asking someone to download a separate app and go through all these steps. Some other examples of this kind of use case could be insurance, banking, or one that might be kind of relevant to some folks in the room. If you're doing a coding interview where you have to do a whiteboarding session or sort of like a VS Code live share style thing, you could actually build your own version of that using WebRTC. So WebRTC is real-time video, audio, and data experiences for users. And really the powerful part of it is that it is so customizable, and it handles a lot of the tricky networking things that are really like a pain in the butt to try to figure out. It handles all that for you so that you can just focus on the user experience. It's available on all browsers. There are also iOS and Android libraries if you prefer to work that way. But really, if you've got access to Firefox, Chrome, any of the modern browsers, with the exception, again, of a few, you can use it. You can build an entire UI experience. Even if you're just using vanilla JavaScript, you can really go a long way. All the demos that I'm going to show today are all written in vanilla JavaScript. No libraries or frameworks, but certainly you can use those. And there's tons of like React frameworks, for instance, that you can use with WebRTC. It's also secure. Obviously, security is a huge concern. And because it's peer-to-peer, it's a secure choice. We'll talk a little bit more about what peer-to-peer really means here, because there are some things that you have to take into account as you're scaling and you're getting more users joining in on a call. So today we're going to talk about the basics of WebRTC, kind of what actually happens when you say, I am user A, wanting to connect to user B over a peer connection. We'll talk a little bit about how you can create a really great experience for the user and some different features that you might consider using customizations when you're using the WebRTC APIs. And then lastly, a few tools about diagnostics and then takeaways from the session. So, diving into the basics of WebRTC, if we think about how we would want to start a connection with another user, we'll think about maybe an example where you have 3 devices that all want to connect. So you've got a phone, a laptop, and a desktop computer. So the first thing is all of the devices need to let each other know that they're available connect, and they do this through a process called signaling. So WebRTC doesn't handle the signaling process, but it doesn't care how you do it, really. So the way that we'll talk about doing it today is by using WebSockets, because this is something that a lot of people are familiar with using, and it's available as an API as well. You can also format the data however you want to format it. Formatting it via JSON, if you're using WebSockets, is kind of the use case that we'll look at for today. And then there are a couple of different ways that you can actually send the media back and forth. The easiest and best case is peer-to-peer. So if we're all on the same network, we all have a private IP address that's unique to our device, and then the public IP address of the router that we're connected to. So if we're all on the same router, then we can all connect to each other pretty easily. We can share the port number we want to connect on, and it's really great. The only problem is because we're sharing data directly back and forth, as you can imagine, the more peers you add to this, the more difficult it becomes to keep things moving quickly. It's really hard on the CPU. It really affects the bandwidth, and so this is great if it's just a few devices, maybe if you're like doing a demo, but if you add more into the mix, it's not going to be a good experience. So at that point, you probably want to use a media server. So there is a type of server called a selective forwarding unit, or an SFU. There are a few others that you could consider. There's one called an MCU, there's one called a mesh. We won't get into that today. Those are kind of more advanced cases, but the SFU is really great. It sends all the media to that server, and then the server handles sending it back out to all of the peers. The SFU can also customize some different things on it, so it can re-encode the video if it needs to. It can manage some of the bandwidth, so it can actually provide kind of a better experience if you take advantage of some of the things that you can configure on it. So I found this blog post by the team at Signal that was really interesting, and they highlighted a lot of the SFUs that they looked at when they were building their own SFU. So their SFU, it's closed source, and you can't use it yourself, but you can use some of these open source SFUs that they actually modeled theirs off of. So if that's something that's interesting to you, definitely dive into that a bit more. Okay, so let's talk about ICE and NAT. Get ready for a lot of acronyms. So ICE stands for Interactive Connectivity Establishment. And really, what it's trying to find out is, what is your IP address? What's the IP address that you need to send to the peer so that they can connect to you and you can start sharing audio and video and data? It does this by using a network address translation. And so basically what's happening is it's trying to use NAT to find out behind the public IP address on my router, what is my private IP address? And it kind of does that translation between the two peers so that the private addresses stay protected. So again, if we're peer-to-peer, then it's no problem. We really don't have to go through any of these other types of servers. However, if we're not on the same network, then we do have to use STUN, which is Session Traversal Utilities around NAT, or for NAT. And so STUN is really great. It is going to be the default. The cool thing about ICE is that it's kind of running all of these processes in parallel. So it's going to try to connect peer-to-peer. If that fails, it's going to try to connect to STUN. And stun, there's really no problems with it, except if you run into a firewall or a proxy, which again is something you probably all will run into because a lot of people are connecting through their work networks or things that are protected in some way. So if this happens, then you have to connect through what's called traversal using relays around NAT. So because it just isn't going to be able to connect via a public IP address, it will have to kind of do all of these things that go around the NAT. It is more expensive, so you are going to have to figure out a way to manage the costs. You'll probably want to protect it behind a username and a password, just so that you don't incur extra costs from folks using it. So let's dive into the APIs now, which is really like the most exciting, important part of this talk. So there are 3 APIs that WebRTC is based around. The first one is media capture. So this API is going to get the devices that you are able to connect to on your machine. Once it gets permission from those devices to connect, it will grab the inputs of the video, audio, and the data to relay over. The next one is the peer connection. So this is what's actually going to use those ICE servers to try and make the connection to the peer. And then we'll feed the stream of all of the data that we got into that connection over to the peer. And then the last thing, I think, is kind of the most fun one, because it is like choose your own adventure, throw whatever arbitrary data you want into the WebSocket and send it over to the other peer. And I have some demos that kind of show some fun ideas of how you might use this. So get user media is really kind of the most important API out of the bunch, because if you can't connect to a device, then you can't get any media or any data, and that's really why we're doing this in the first place, is so that we can see someone else on their screen or hear them. So you have this constraints object, and you'll see, you can customize it, so you can set it to true for audio or video or both. And there are actually some instances where you might not want both. I have definitely had to do the sort of like image verification before, where it's like take a video of you going like that, or positioning your head a certain way. So if you're doing something like that, you actually don't need audio. I run a podcast. I've thought a lot about what would it look like to build a platform to record my podcast off of, and I don't do any video for my podcast. So if I wanted to just get the audio data and do it that way, then that would really actually make sense for this case. This is also assuming that someone will give permission. And then we just can do something with the data, but we'll talk a little bit about what would happen if someone didn't give permission and how you'd handle that. This API used to return callbacks. It has evolved over the years, and now it returns promises. So if you would prefer to write it in async await, you can absolutely do that. So the next API that we're looking at is get peer connection. And this one is doing all of that work of getting us connected to the other peer. So we're going to create the object and then feed in ICE servers as the argument. And so ICE servers is going to be both the stun and the turn server, because again, if stun ends up failing, then it's going to go over and try the turn. Once we get a candidate, that candidate is actually our IP address and the port number. So once we have that, we can go ahead and try to send that over as the signal to the peer. We're also going to add the stream of the media that we were able to get in that first get user media call that we made, so that when we hopefully have an agreement, we can start streaming the data immediately. We're going to create an offer, and the offer essentially is all of the information that the peer would need to know about your browser. So in addition to all of the candidate data, it's also things like what do you need to encode your media as for me to be able to read it, any of the other constraints maybe that they've put on their data that we need to know about before we try and send something over. And then we're going to set our remote description to that offer that we just made. So the other peer, as it sets the remote description, and then it will kind of check the offer that we sent over and see if it's actually compatible with what they have. And then if that does happen and it is compatible, then it will create an answer that it will send back to peer A. And then at that point, hopefully, we have a successful connection. And we can go ahead and we can start streaming all of the data. And then at that point, we can do something fun in the UI and go ahead and actually display the video that we have, play the audio that we have, or do something fun with the data that we have in the data track. So this is the data channel API, and it's pretty straightforward. All you really have to do is just give it a unique name of what you want it to be. And then we just start listening for the data. And it is a WebSocket connection, so you do need to open the socket. But once the agreement's been made and that's open, we can start sharing things back and forth. So now that we kind of know the inner workings of these APIs and sort of the order in which they're run, let's talk a little bit about the user experience. So in terms of media, again, we looked at media earlier and we were assuming, okay, this is always going to resolve. Someone will see the permission dialog box pop up in their browser and they will agree that they want to share their video and their audio. But unfortunately, that's not always going to be the case. Perhaps they explicitly say they don't want to share, or maybe they have operating system settings that have prevented them from sharing, which is something that has happened to me in a live demo recently and was really embarrassing and difficult to figure out. But we do want to let the user know if, for some reason, we can't access the other user's video or audio. We don't want it to just fail silently and them not know what's going on. We aren't able to get more information about why it's being blocked, if perhaps another application is using the video. So it won't be as descriptive of an error message, but it is good to provide something there. In terms of the constraints around the video and the audio media, there are a few that are maybe helpful to be aware of as you're building these experiences out. One of them is facing mode. So if you are building something for mobile, if you think about the way that your phone is, you have the camera that faces you and the camera that faces out into the environment. And if you're pretty sure that people that are opening this link or coming to the WebRTC sort of in-browser experience that you've built, if you know they're coming from mobile, then you can set this to be facing them so that that's already just something that's ready to go. Because if you're like me, you've also probably been on a call where the video is set to facing outward the whole time and the person can't figure out how to turn it the other way, and then you're like looking at the corner of a room the whole time. There are these other settings as well. Environment is the one that kind of faces outwards, so that's straightforward. I've looked a lot into the right and the left options, and I haven't really found any like typical real life person use cases for these. There were some awards shows, like big, Hollywood award shows that were done during the pandemic that used WebRTC. And so for like a big multi-camera setup or something like that, right and left could be used. But if you're just kind of an average person, then I don't know that those will be the most applicable. But if you know any use cases, I would love to hear about them. So definitely let me know. The other thing that you can do that I think is really useful is you can set a unique device ID to the devices on your machine. So if you know that you're going to be logging into this and you have different, maybe you have like an external camera and then you have the internal camera on your mic, or on your computer, and then you also have like your microphone and maybe like a USB mic, you can differentiate between these two and choose between them. And that's a really important part of the user experience, is allowing users to decide which device they want to choose for the input. It sounds obvious, but it's actually like something that does take some intention when you're building this out. You can use this enumerate devices method to go through the devices that are connected. And the other good thing too is that way, if for some reason the device isn't connected on the user's end, through no fault of the application, that's something that they can then explore, knowing that it's not set up properly. The one thing is that if a user doesn't give permission to the browser to see their devices, then it remains anonymous. You might actually see like the number of devices that are connected, but you won't have any information about like the descriptive name of that device, whatever the brand of it is or that kind of thing. So Now that we've kind of gotten our way around this, I'm going to show a quick demo, and I just wanted to give a quick shout out to my colleague Phil. If you all come to NDC every year, you may have met Phil before. He authored these demos that I'm going to show, and they're really well done. So the first thing we'll look at here is just the camera selection. So on the left-hand side of the screen is Firefox, and on the right hand is Chrome. So we'll kind of just look at some of the differences and the similarities between them. So if I choose Get Camera here, it's going to give me some options about how I want to connect, and we'll see if my cam link actually does work. I have this camera set up over here. This is usually what I use for my webcam at home. And then there's also like the internal camera, which is the FaceTime one here. So it's interesting because Firefox has this remember this decision link or checkbox, and it actually won't remember. So that's not really super useful, but that's okay. Cool, so this is working, which is great. You can all see yourselves out there now. And then if I wanted to change over to my FaceTime camera, for instance, if I just click this here, I'll have to give permission to that as well, and then you can all see me. So then if we go over here to Chrome, it's pretty similar. It's, still doing this thing where it asks permission now, and then you'll see all the ones I have here. There's this OBS one, which I use sometimes for streaming. It's a virtual camera, so it's actually not really going to do anything here. And then let's talk a little bit about resolution, because that is definitely something that is worth kind of exploring and thinking about if you are building with WebRTC. So 920 by 1080 is kind of like a standard that we could put in if we wanted to. It's best to give some different options. So the minimum, the maximum, and then the ideal. And so as you can imagine, as the browser window size moves, it's going to try to hit one of these. The one thing that you do want to kind of avoid is this one called exact. So if you use exact, then it's only going to try exactly what you gave it. And if it can't reach that, if it's over-constrained, then you're going to get this over-constrained error basically saying, this is too big and I can't do it. So we'll just take a look at what this looks like really quick. So I'm going to minimize Firefox here, and we will just use Chrome. So the cool thing about WebRTC, of course, as well, is that it is built entirely in the browser. So if you want to make some edits without, kind of like writing something in your IDE and then refreshing it, you can just go over here and kind of have a play around with it. So that's what we're going to do. So right now, we're looking at this video constraints object, which we've declared on line 32. So I'm just going to go in here, and then I'm going to change the width of it. So we'll do it using that first way that we looked at. So we'll give this 320, and this will be 1920, and then ideal. And then for the height here, I always forget this resolution, so we'll see if I get it. And then we're going to look at this, and then we'll look at the exact, and you'll see kind of what can go wrong if we go about it that way. All right. So I'm going to save this. And then if I go over here to Get Camera, you'll see that it did change our resolution there. So that's good. That's what we wanted to see. Now I'm going to go over here and just change this to exact. And so again, the browser is just going to try to get exactly what we have given it. And it actually probably should be fine for my Camling one. Yeah, so that's working fine, but let's see what happens when I try the FaceTime one. Oh. Oh, thank you. Okay, there we go. Exciting, very paradoxical when you do the thing that you don't want to do. But we got the error here, so it can't get this resolution that we wanted. And then if we go to the console, we'll see we did get that over-constrained error. So just something to keep in mind, again, as you are thinking about, the experience that the user might be having on their end. Okay, so the next thing that I'll mention is another sort of mobile little feature that you could add in potentially if you know someone is going to be on mobile, and it's actually like the torch or the flashlight on your phone. So if you set this to true, then it will automatically turn the torch on when someone connects via video. And you may think, okay, well, if you use true to turn it on, certainly you'd use false to turn it off, but that is not the case. You would actually just need to stop the video track entirely in order to turn the torch off. And I think a few use cases for this that would actually make a lot of sense are if you were building a barcode scanner or if you were building a QR code scanner, which is a huge thing, again, that we've seen quite a bit over the last 2 years. The other thing that you can do, rather than constraining the video track as it comes in, as you're asking for it, you can also constrain it after you've already gotten the track. So you can apply these constraints after you've already gotten the video track from the stream of data. The other thing that you want to take into consideration if you are changing the video track itself is that if you want to switch to another device, another stream of data from another device, you can't just go in here and change the device ID because it actually needs to get a different track of data from that other device. So similarly to Torch, you're going to want to stop the track first, and then you can just go ahead and make the request again with the device ID of the one that you intended to use. So it's a good practice just to always provide a way for people to change their device and let them know which one they're currently on and check those inputs. So I will show you a demo of how you can do this. So for this one, let's go back to our split screen. And we're going to see this connection here. And make this one smaller. Okay, so if we preview the camera and microphone here, again, it's going to ask for our permission. Great, so you can see we've got this drop down here, and then we've also got the microphone. So if we wanted to join the room, we could add in our information here. And then I'll just do the same thing on this one. We're actually going to use this next part in a second, but I just wanted you to see what it looks like. So then if I wanted to choose, my cam link here, I could do that. And yeah, this is just like a nice kind of like information for the user to have before they log in. The next part that I'm going to show is actually all around the web audio API. So we'll talk about that really quick before I go into that part. So if you saw that visualizer that popped up, that was kind of like going, that actually wasn't part of WebRTC. That was a different API called the Web Audio API. And it's really useful to use alongside WebRTC because you're already getting that audio data coming in, so you might as well do something with it. And there's also some other things that you can customize that I'm going to show you in a minute that's very relevant to the title of this talk. So you can display audio to the user in a lot of different ways using it. I've also seen people build things where you can like change your voice and kind of like silly demos where you can, like add reverb to your voice or like do really fun stuff. So I think you could probably build like a really great interactive experience with that. And the nice thing is once you kind of understand the media constraints that are available to you, you can really use them to your advantage to make it feel like something easy for the user to use, something like with them in mind, built with them in mind, really. So now I'm going to show you a little bit more about what can be done with the Web Audio API. Okay, so we're gonna log in, and I'm gonna go on mute like kind of immediately, just so that you can see what we're getting at here. All right, and then I'm gonna give myself another name here, just slightly different, so that it won't. Okay, so you can see now that I'm talking, but I'm on mute. So in this demo, it's really great because basically it's taking the audio that's coming in and it's trying to figure out like, okay, the audio is within this frequency, so I know it's probably not background noise, and I know that someone's probably talking, but they're on mute. And this solves the you're on mute problem. So never again do you have to tell a colleague, hey, please come off mute. You can just use something like this. Cool. So there's just a few more things that I want to chat about before we wrap up here. Screen share. So screen share is part of WebRTC, but it's a different API than Get User Media. This one is going to be Get Display Media. So it's pretty similar. It's going to prompt you to share your screen again. And it's just for similar reasons, right? Like you don't want someone being able to access your screen after you've ended this session. That would be really bad. In the past, WebRTC builds were really difficult to build, creating video for the browser was really hard to build. You had to develop plugins that would add on to your browser, and then you had to maintain those, and you often had to create some sort of extension in order to share the screen. So now you don't have to do that. You can just do it all through WebRTC, so it's recommended to not do that. There are a couple of other like fun little things that you can do with, aside from just screen sharing, that you can do with the data channels API. So I'll show you some of those, and then we'll just talk briefly about like what the data channel API looks like. Okay, so again, I'm gonna just share here to this particular demo. And I'm just gonna log in here so that you can really like see what it would look like for two people to join. This one is a little bit different than the other one that we just did. I'm gonna go on mute. And this is, as you can see here, we've got this share screen option. So you can share your screen, although that one looks like it's not working for some reason. So here you'll see, there's this drop down, and you can choose if you want a particular window or the whole thing. The thing that that Firefox does that I think is actually really nice is it'll let you mute website notifications while you're sharing. So if you do happen to have that enabled, I actually think that's a really nice feature. And then, yeah, you've all seen this before, but that's, kind of what it looks like in here. Looks like maybe it didn't share my video. Oh, did I? That would do it then. Let me try it over here. I just want to show the whiteboarding thing, because it's actually pretty cool. Thank you. So there's that, and then there's this fun thing with the data channel API, where Phil built this thing where you can click an emoji that you want to send, but then the more you click it, the bigger it gets, which is kind of funny. You could tell somebody to fast forward or go backward, warn them that they're running out of time here. And then if you wanted to try and make your face the emoji, you could do that. The other feature here that I think is pretty fun is you can do this whiteboard. And this is another library that somebody built that's integrated in this demo, but it's pretty fun. And I know a lot of people use Miro or other whiteboarding collaborative tools now. So those are great, but you could also build your own if that is something that you wanted to do. All right. So everything that we just looked at was built using data channels. And again, really all you have to do is just give it a name and open that up. There are a few other useful tools that you can look at when you're building something with WebRTC. So at Twilio, we do have a video product that's a paid product, but we also have these diagnostic tools which are free. So you can implement them in your own builds, and it will help you test for things like bitrate, video input, and audio output. We also have a site called networktest.twilio.com. And if you go there, it's going to immediately start running a bunch of tests. Some of them, again, are Twilio specific if you're using like our voice services or something with video, but some of them are more general, like bitrate and upload speed. So you can definitely take advantage of that. It'll also do a thing where it will like set up an automatic call and make sure your audio inputs are working. So that might be something useful to you. As I mentioned earlier, not every browser does accommodate WebRTC, but if you look at this, I would say the coverage is pretty good. All of the green, are browsers that do allow for WebRTC, and if you are building something on Android and you're worried about the native browser not working, there are those libraries for if you want to build something for Android. So hopefully by now you know that WebRTC is not a solution. It's not a fully fledged thing that you can just go and deploy and use, but I actually think it's good that it's not a solution because it gives you the power to build what you want to build. It really is everywhere. So anywhere there's a modern browser, there is the potential to build a WebRTC experience. It's powerful because it's on the web. We have all these other apps that allow connectivity, but they don't allow for the same sort of customization or fun that something like WebRTC does. And then hopefully you leave this talk today feeling empowered and maybe have some ideas yourself that you could use to create your own WebRTC experiences. So thanks again so much for spending your lunchtime coming to this talk. Hopefully you learned something new or maybe just got a bit of a refresher. And again, if you would like to reach out, please do so at my Twitter, my email. I would love to learn more about what you're building, and have a great rest of your time at NDC.